Okay, let's look at our third example, right? Let's look at our third example. And as I'm reading this, this clearly should say example 3, right? So we're looking at our third example. We're going to graph the function h of x equals 2 sine 3x on the interval 0 is less than or equal to x less than or equal to 4 pi over 3. And actually, let's change this. Let's change this and make it a little bit more interesting. Right? Let's say that we're going to graph it on the interval 0 is less than or equal to x less than or equal to pi. Okay? I'm going to make this a little bit more interesting for our graph. Now, we discussed previously how our cosine function starts at a max, right? And at the beginning and at the end of the period, it's at a maximum, right? In the middle of the period, it's at a minimum, right? And it's on the so-called center line at 1/4 and at 3/4 of the period. So that's my basic shape for the cosine function. This is dealing with sine function. Our sine function is slightly different, right? Our sine function, right, if we still think of our center line, our sine function starts on our center line, goes to a maximum, comes back to the center line, goes to a minimum, and then comes back up to the center line. So that our sine function would have that general shape, right? And these tick marks are there to help you out so that if I say, hey, on my center line, go to a maximum, on my center line, go to a minimum, go back to my center line. If you use the dots, it can help you draw out your graph a little bit better, right? And we can think about this as our center line. That's going to be our basic graph for the sine function. So here we're going to do 2 sine 3x on this interval, right? So I'm going to come over here, draw my axes, right? And for this particular graph, it does not appear that we have a vertical translation. So our center line is just the line y equals 0. Okay, and we also have an amplitude of 2, so we'll say up 1, up 2, there's 1, 2, down 1, down 2, there's -1, -2, right? Because I understand that for the sine function, our range, right, is typically -1 to 1. However, because of our amplitude of 2, our new range is from -2 to 2. Right, so we have that drawn out. Once again, right, we're going from 0 to pi, so we're not exactly sure how much we're going to draw, but we do know that, you know, every time we're going to draw one period, right, we can set up with our graph like this. So we say, right, 1, 2, 3, 4, that represents a full period, right? Our period is 2 pi of the absolute value of b. B in this case is 3, so our period then is simply 2 pi over 3. That means that that value right there is pi over 3. Now, 2 pi over 3, excuse me. Now, half of that is pi over 3, which then means that if I go another half period, right, so just 2 tick marks, that will take me to pi, right? So now I have the interval that I want from 0 to pi. If the interval was 0 to 4 pi over 3, that would have been 2 full periods, but we're not going to draw 2 full periods here. All right, sine function starts at 0. Halfway into the period, it's at 0. At the end of the period, it's at 0. All right, then once again, halfway into the period, it's back at 0. So I can look at it here, just every 2 tick marks, I'm going to be on the line. Right. My maximum is at +2, so at 1/4 of a period, I go up to +2, and at 3/4 of the period, I'm at a minimum, right? Next, then I start again after I draw this in, right? So here's one period. Then at, once again, 1/4 of that period, I'm going to go to a maximum, right? And I'll come back to 0. And there I have the graph of 2 sine 3x on the interval from 0 to pi. Notice how we have this drawn, right? We have the labels on the axes, we got them both axes, and we have our general shape. Well, we understand what our general shape should look like. We need to be able to draw these graphs without a calculator. Hopefully with these 3 examples, you feel a lot more comfortable.